In this tutorial, a PVMapper site designer, we will discuss the design of a photovoltaic system. To download PVMapper site designer, go to pvdesktop.codeplex.com and download the latest version. Once you open the site designer, you'll be able to select a different base map that you like to use. Only data showing right now are points for the different weather stations. First, you'll want to zoom into the location where you like to create your site. Now with the Select Site tool, you'll pick a point on the map. This is the point that will be referenced to for any weather data used to calculate solar information. You'll see that its coordinates are now uploaded into this section. You can now zoom to this site from any point on the map. Under the SunPath tab, you'll be able to find additional information about the radiation at this particular location. This table here tells you how many hours per year of sunlight is received at different azimuth angles as well as elevation of the sun, portrayed visually in a solar rose diagram. The colors represent the elevation in the sky. And now we can hide the solar rose diagram so it doesn't get in our way. Now zoom back into our site. To create solar obstructions, first turn on the Buildings tab, create a new shapefile, and select that layer. Using the Drawing tool, for each building on the site, simply draw the perimeter, select Finish Shape, and we can do the same thing for each building on the site. Now to add the height of these buildings into our attribute table, we'll select the buildings, click on Building Attributes, and if they're all the same height, you can go ahead and populate the table and save it. Make sure to save your data. We can now verify that each of our buildings has accurate height data and create shadows for the buildings, which represent shadows over the entire year for that building. We can go through the same process by turning on the Tree tab, creating a new shapefile, selecting that layer, and using the Add Shape tool, simply select the center of each tree that is in the vicinity of your solar system. You can now select each tree that has the same shape, diameter, and height. Enter in its diameter and select the shape of the tree. For this one, we'll select oval shape. Click on Tree Attributes and populate that information into the table and save it. We'll now select the remaining trees on our site. And we'll use the vase shape. These trees are a little smaller. We'll now populate that data. Again, make sure to save your information. Verify that each tree has the information necessary, and we can now create the shadows created by these trees. You might notice now that the SketchUp tool is now active. If you click on it, you can save the data for both the buildings and the trees. I'll go ahead and save it to my temporary file. And once it's been saved there, we can go to Google SketchUp and open that file in SketchUp. In SketchUp, you'll want to go to File, Import. Go to the same directory where you saved your data. And you can see here that the tree and building data was successfully imported, and you can have a visual of what PVMapper Site Planner is seeing. Now that all of our solar obstructions have been created. You can go to the Layout tab and begin to design the layout of our solar panel system. We can do so by choosing a site area or by alignment, and today we'll do it by alignment. Again, we'll create a shape file, select that file, and using the draw tool, we're going to draw the alignment, right click, and click Finish Shape. You can create as many lines as you would like. Click on Position Panel, and we'll enter the spacing that we like on our alignment. Today we'll choose a spacing of 2 meters. We'll populate that information to our table, and we can now see that the location of our panels has been created, represented by points on our line. Now to select the spacing that you would like for each of the alignments, simply go to the table. We'll do 2 meter spacing. We'll save that data, and we can now see that each of the panel locations is represented by a point on a line. We'll now select all of the panels that will have the same attributes, and we'll set their tilt angle. We'll set that to 40 degrees, and we'll also select their angle of orientation or their azimuth angle at 180 degrees, and we'll populate our attribute table. We can see that our azimuth and elevation angle has been populated. We'll save that, and we'll go to the panel size to assign size of the panel, which will apply to all panels. We can go to our attribute table if you like and see that all the information is now populated, including the width, height, azimuth, elevation, angle, and the coordinates of each point. Now we can create our PV panel system and see that it's been laid out along the alignment. The final step is to calculate our energy production, which we can see in this table given monthly, and if you were to have panels that had different orientations, they would be listed separately. We can toggle back and forth between our map and our table up here. Now the final application is a rooftop design. We'll go ahead and locate a rooftop. Alright, we'll go ahead and use this building here. Let's zoom in a little closer. We'll go ahead and put some solar panels on the south side of this roof here. First thing we need to do is draw the ridge of the roof, and I'll just use this section here, and then we'll select the eave. There's no need to right click, simply just click twice, once for the beginning point and the end point. This roof is pretty shallow, so we'll select a 12:1 pitch, and now we'll generate the roof plane, which will now have a nice polygon here that dictates where our panels will be placed. You can see that these fields have been populated with the height of our roof, as well as the tilt and the azimuth angle of our roof. We can now select the spacing that we would like with our panels. We'll go ahead and do 2.5 meter horizontal spacing. I'm sorry, 2.5 meter vertical spacing and a horizontal spacing of 1 meter, and we'll now create our location of our panels. In the same process, we'll select the size of our panels that we like to use, apply that to all panels, and create our arrays. So we now have a nice array of solar panels on our roof, for which we can also look at the energy calculation per month. Thank you for watching this tutorial, and I hope it has been helpful.